we're moving into a world where software is essentially inorganic. You can't put it in a box and say, this is what it does. This is what it might do is the world we're going into. But this is what it might do opens up a whole world of possibilities. And thinking about the whole stack of software is going to be reinvented.
From Next 47, this is the AI Unveiled podcast with me, Gaurav Kotak. In this episode, I'm speaking with Tariq Rauf, the founder and CEO of Qatalog. Qatalog offers a knowledge intelligence platform that automates and streamlines workflows for teams across databases, tools, and software. In this episode, Tariq covers which use cases are powered by generative AI and the tech stack needed to implement the ideal solution. He also dives into how Qatalog goes against the grain with both their approach to vector databases, as well as how they search across vast amounts of information. I hope you enjoyed this episode with Tariq Rauf. Let's get right into it. Hi, Tariq. Thanks so much for being on the AI Unveiled podcast.
Hi, Gaurav. Thanks for having me.
I'm excited about this. On this podcast, we're speaking with successful SaaS and technology companies that already have a product, already have users, and are now incorporating AI to turbocharge value for their customers and their business. And the goal is really for other builders to get tactical, concrete advice. Tariq, I feel Qatalog perfectly fits the bill. So for those who may not know, could you give us the summary of what Qatalog does?
Qatalog is a knowledge intelligence platform. So we enable real-time access to information across systems and automate workflows across tools, all from a single natural language interface. This means anyone across the entire organization can ask a simple question, and give a simple task and get an accurate answer or a result in just seconds. You can imagine things like, locating a particular document, understanding the status of a project, knowing who owns something, surfacing some sort of critical data, finding the synopsis of something like, what is our OKRs for this quarter, or answering a knowledge-related question or a customer support-related question or a product question across any information that sits anywhere that we can connect to. We will bring it up to the user.
Yeah, and knowledge retrieval is a very difficult problem. And it seems like you can help me reduce the number of tabs that I have open in my browser. For that, I am very grateful. But before we get started into kind of the artificial intelligence itself, could you just tell me a little bit more about your background and how you got started with Qatalog as the founder?
Before Qatalog, I was mainly in startups and large tech companies. I started coding when I was 6. Eventually got to the world of startups about 12 years ago. I started working in this early stage company called Hinge Health. After that, I worked at TransferWise, which is now called Wise. And then I moved to Amazon shortly before I started this company.
Amazing. And you were on the Alexa team at Amazon, if I have that correct?
We cut across, we are the digital team, so we did Alexa, video, music, photos, Twitch.
A lot of natural language processing there. Anyways, let's jump right in. How do you use artificial intelligence in the Qatalog product? And specifically, what use cases and what's the experience like?
So we use AI across the stack. We don't use it just at the UI layer. We use AI at the infrastructure layer. We use AI at the business logic layer. We use AI at the UI layer. We use AI at the input layer. So users can use natural language. Our UI is constructed on the fly using GenAI engines. Our logic is determined on the fly using GenAI engines. Our infrastructure is essentially a loosely coupled set of components that are assembled in real time using AI engines. So we use AI up and down the stack, and we've completely rebuilt everything across the business using GenAI.
Wow. Yeah. And we'll talk a little bit more about the kind of implementation and lower down the stack, but just on the user experience itself, maybe could you first jump into, you said information search and retrieval. Talk a little bit more about how generative AI, or AI in general, makes the experience more personalized or better for the end user.
So prior to this, we essentially had lookup engines, keyword search, and to some extent, vector databases enabled semantic retrieval. But in order to do any of these things, you needed to hold a copy of the data separately across, if a business had 20 tools and they had, 500 gigabytes worth of data, you would have to usually copy that over to an index or convert that into embeddings and store it in a vector database. And you can imagine how complex and sophisticated and costly that is. And this new paradigm enables us to essentially leapfrog that requirement and use AI to non-deterministically find the data sources where a specific question might be held, the answers to a specific question might be held, use AI to sort of understand, sift, and sort through tremendous amount of results that come back, and then synthesizing that back to the user. All of that is now through Gen AI.
And you talk a little bit about, so what your product does, of course, it connects different systems like Slack, like Google Drive, SharePoint, etc. And let me make sure I understand this correctly. With some of the generative AI techniques, you no longer have to copy and index all the data. So in a way, it's less costly for you and your customers, probably more privacy aspects to that, because every time you copy data.
Exactly.
Just elaborate a little bit more on how exactly kind of you were able to accomplish that technically.
Our engine is called Action Query, and we have essentially decomposed the problem of information retrieval and search like how a human would, and we have enabled Gen AI to essentially behave like this. When you search for something, we're not doing a keyword retrieval and then showing you the results. We're searching the systems like a human would, if that makes sense.
Yeah.
And so today, imagine if you're looking for information, what you would do is say, oh, that looks like a something that's got to do with engineering. Engineering is going to be in Jira. And I'm going to go and search in Jira and find these 7 tickets. This person's looking for this thing. In these 7 tickets, this might have the answer. And within that, here's a response. And so we're essentially automating that workflow with AI on the fly, rather than needing to keep a store of that information. So we're essentially a stateless machine that sits on top of the existing systems that somebody has. And the AI essentially works in real time to get the answers back for the user. This just wasn't possible a couple of years ago, for instance.
That's really cool. So rather than indexing the universe of data, you're literally acting like a human, making a determination on what are the most likely systems, and then going deep and using natural language query. I mean, we hear a lot about Copilot for X. You're really building a Copilot for information retrieval in a very humanistic, human-like way in the enterprise. Yes, exactly. Yeah. And you talked a little bit, before we go into the implementation, you talked a little bit about the UI is constructed on the fly. And you also touched upon there are also commands that Qatalog can give. It's not just a read, right? While the read is the predominant.
Now, let's say you are asking for what is the revenue for the last couple of quarters from European customers, and the information for that. You can say, show me the trend of the information for the revenue for the last couple of quarters for European customers. There's going to be a graph, and so depending on the query, the UI is essentially determined on the fly. And the components for that are rendered on the fly. So there is no deterministic logic anywhere that says for a graph query, render the graph component. For this query, render this component. There's no mapping anywhere. The AI knows that for this type of information, you might want to render this type of UIs. And then, use the logic held within the model layers to define that essentially. And so the same thing with, give me, when did we last launch X? And that's going to give you a date. And that date can just be a small summary on top of the search results. Or if you say, I want to take time off next week, then the UI needs to be, what is the reason for that time off? What's the start date and end date? And what's the category of this time off request? And then that goes and pings Workday. Now, we don't have code anywhere that says, here's how you book time off. All we have are the Workday integrations and the user's request. Everything in between is essentially assembled by AI.
And how is AI figuring that out? I get the information retrieval. Mm-hmm. What's the right UI? Mm-hmm. How is AI figuring that out? It's unclear to me. It's amazing, but I think it'll be, and don't give away too much of your secret sauce, but I'd love to kind of better understand that a little bit more.
So one of the way we look at Gen AI is not as a text generation machine. We don't look at it as a conversation engine. We've designed our AI backends essentially to be logic machines for a specific setting. What used to be deterministic code is now probabilistic. But, we've taught these endpoints to define just the output it needs. We'll have an endpoint somewhere that says, determine what type of UI needs to be rendered for this type of input. And we probably have trained with thousands of examples of what needs to happen in specific scenarios. And we let the model learn that over time, over thousands of scenarios, and have a very specific model that does that very specific component of the problem.
Yeah, I mean, we talk all the time about generative AI and creating text or even creating multimedia, but you're actually creating the user interface on the fly, which is really interesting.
Yes.
What about chat as a user interface?
We think chat is sort of skeuomorphic stepping stone to what the real UIs LLMs will eventually enable. So chat is almost like, when you had keypads on mobile phones before, you had these single screen experiences. They're essentially a Frankenstein approach to, the ultimate experience that is fully LLM native. So before you had these side by side, the screen here and a input screen all the time next to the UI, and that affected how you built the UI. The UI had to make space essentially for the chat interface. Now, eventually, those two fused, and when it fused, there were net new paradigms that were enabled that just wasn't possible before. The touch combination of the real estate increasing and also multi-touch becoming really, really good led to net new interfaces that were natively full screen.
Mm-hmm.
And so I think a similar sort of end state is possible with LLMs, where chat is essentially the keypad into the UI, where you're controlling stuff from the UI or getting stuff from the UI, but it is a skeuomorphic sort of halfway house. Eventually, you're going to see LLM native, probabilistic UI native, sort of generated workflows on the fly native experiences that just aren't possible today happen. And that's going to be when we really compress the logic, compress the workflows, compress the user journeys into something that just isn't possible today. And Qatalog is an example of that sort of paradigm where we have a prompt interface. We don't have a chat interface where you say what you want to do. And depending on that, we render the next sequence of steps. It's not a turn-by-turn conversation. It's a turn-by-turn UI, but it's not a turn-by-turn conversation. And we sort of orchestrate that turn-by-turn based on what the user is trying to do.
Yeah, I was just going to say chat, as most people think about it, is a text box with kind of text on each side and pretty single modal. And what you've done in Qatalog is still there's a turn-by-turn, let's say, interaction pattern, but each turn, the UI is customized for the content that's being returned. So it's much more richer. And I don't know if I want to call it chat, but maybe, as you said, I think you would, different prompts and takes.
User interface.
User interfaces, exactly. And I'm guessing you can also control the accuracy and not make sure that sometimes chat is fantastic because you can go back and forth, but sometimes it can go off on a tangent, if you will. What are your thoughts about that?
So context sort of containment and objective containment in a long chat back and forth is very difficult. Where does the last context start and where does the next one begin? This is one of the reasons you have, chat threading in OpenAI, where you have for each new thread, they create a new context. But that's not essentially possible all the time if you're building LLM native products. How do you contain the context from one request into another, one situation to another? And so the UI needs to be sort of constrained from that perspective. And there are all kinds of tricks you can employ to do that. But if you use Qatalog, if you look at some of the demos of Qatalog, that'll give you a sense of essentially one of the approaches we've taken to do that.
Yeah. So chat could make sense for your use case, but even in that, you may want to make it richer each turn. Yeah. And in some use cases, the expectation is not to be conversational back and forth, but a little bit more zero shot. And so really it depends on the use case and what it's being solved. That's really insightful. You mentioned the word probabilistic a few times, right? And unsurprisingly, but one of the challenges of any stochastic or probabilistic model is accuracy, right? How do you deal with it? How do you measure it? How do you know that the experience is good enough to launch with your customers?
So the only part where it's very difficult to deal with accuracy is when, and in generative AI, in LLMs, is when information is being retrieved from the model layers. So it's essentially retrieving data from training data. And there's high chance of hallucination because it's extremely probabilistic retrieval, as you said. But we don't do anything that requires retrieving anything from the model layers. So for the UI pieces, we have extremely strong training data that has, no chance of outside possibilities coming out of the training data, for example. The same with information retrieval. We don't use LLMs to retrieve information from the model layers. We only retrieve information from the actual systems of the business. And so there's no chance of hallucination in these scenarios because we restrict it to what we train the systems with and the information retrieved from the systems of the business.
And it's because you're mimicking a human, you've already got those guardrails in place when it comes to the universe of options. My next question was going to be about, how do you deal with permissions and personalized experience? But I think the answer lies in the fact that you're not going from the universe to figuring out permission sets. You're just acting on my behalf and, short-circuiting a bunch of steps that I would need to do for me, right? And I think that answers the question, but I should just kind of ask for your confirmation anyways.
We use the user's tokens, we use the user's authentication, we use everything that the user currently has. So we don't need to rebuild a permissions graph, copy over all the information along this permissions graph into a new system, and then keep that permissions graph in sync with your business systems. All the complexity and security breach exposure that brings, everything is avoided essentially by acting on behalf of the user and using the user's tokens and existing permissions. So you'll never be able to see anything that you already don't have access to, and you won't be able to do anything you don't already can.
It's very innovative. And if I were to guess how Qatalog worked, knowing your functionality, I would have guessed the reverse of that, which is pretty incredible to hear. So always something to learn, but makes a lot of sense. Let's just dive into the technology stack a little bit, right? Because we have builders trying to figure out these options. Maybe to start off with what foundational models do you use, and how did you come to that choice?
So for the longest time, we just used OpenAI GPT-4. But now we've moved everything over to Llama 2. We have our own models that we have fine-tuned. So we keep everything in-house. We keep all of the systems tuned and delivered and maintained and monitored within our infrastructure on GCP.
And how much was the move to Llama 2, which is open source and on your GCP, right, a accuracy related or maybe user data privacy related, right? What were the factors, right? The predominant factors in that switch?
The primary one is control. This is the core engine of our business. And if the core engine of our business is running off of an API that can go down anytime, we have enterprise customers, we need redundancy, we need scalability, we need failovers, we need all kinds of things and performance control. If we need to increase the token inference rate, we need to be able to invest in GPUs and make that happen. Whereas in GPT-4, you don't have, it's what you see is what you get. And you can't, if you choose to spend 10 million more on infrastructure this year, so the customers get their responses in milliseconds rather than seconds, you can't do that with GPT-4. The second is control over essentially, GPT-4 can be deprecated in a year. And we can build ginormous systems on top of how GPT-4 works. And if you implement it at the depth and level we have, where it's at every layer of the business, that being out of our control is not necessarily a good thing to essentially have. The third is we can get accuracy is not a problem when you have large data sets to train from. If you're essentially using the model for what it is, and using it, at face value, then, GPT-4 is a much bigger deal than GPT 3.5. That's a much bigger deal than GPT-3, for instance. But we have very specific machines that do very specific things in a much larger ecosystem of models. And so we were able to contain the blast radius of the probabilistic nature of the system by containing it with very specific models that do very specific things. And Llama 2 is a godsend from Meta in terms of, one, the base capabilities that it comes with, but also, the tunability, the reliability, the performance of the model is extremely strong. In fact, the fine-tuned version of Llama 2 performs much better than the fine-tuned versions of OpenAI.
And so one approach that I see companies take is maybe use OpenAI and then use vector databases to actually do the personalization. And it seems like, and it's interesting, you said vector database in the pre-world, not in the post-world, right? So just to clarify, you've gone from potentially using vector databases for similarity search to kind of then going on a model where you have high level of control by feeding it the data sets and using that itself kind of as a way to fine-tune the model versus starting with a vector embedding, which is again a pretty common technique for people that are using, especially OpenAI.
Yeah. So I think vector databases are very meaningful and powerful when you have small data sets, when you can get away with low precision, low accuracy, and, things like customer support use cases, things like knowledge-based retrieval, when the knowledge base is like, a shared resource amongst the company.
Yeah.
And it's just maybe a few hundred pages or something like that. Vector databases start to fall apart when the data size is large and the retrieval needs precision and accuracy. So if you're in, say, a large financial company, fintech, or a financial organization, and they have tens of thousands of documents being produced every month, vector databases work with semantic similarity. And so the possibility of a clash in a database that large is very, very high. So you're looking for a needle in a haystack, and every time you find a needle, there's another layer of needle in a haystack that you have to do to find the information. So when the information set is small enough, it's meaningful. But when it gets out of hand, the recall drops, the performance drops, the scalability drops. A whole bunch of things just don't fundamentally work with that technology. So vector databases work on something called ANNs, which is approximative nearest neighbor search. So maybe taking a step back, vectorizing information, there's inherently loss when you go from a high dimensional string into a vector. And when you store these things in a vector database, there is a loss because there's clustering of information. So semantic clustering happens when there's a lot of material that are of the similar vein and match the query. And so retrieval is lossy. The conversion is lossy, the retrieval is lossy. And when you query against this database, that mechanism is also an approximation. And so the whole system is extremely approximative. And so in situations where approximations work really well, and that's when the data set is really small, or where the use cases you can get away with, 60%, 70% accuracy.
That's amazing. And I think you really laid out kind of some of the trade-offs you need to make. There's no right answer, right? I think there's a Sequoia report where vast majority of SaaS startups and scale-ups are actually using vector with Gen AI. Probably it's also the quickest to build. But kind of my takeaway here is, one, understand your business case and your functional requirements. And second, you've in a way chosen the hard way because it's so core to your business, right? And your the complexity of the problem you're solving is, again, heterogeneous data, high accuracy, and kind of that co-pilot nature, which also I would imagine the vector database approach probably doesn't lend itself really well, just thinking through those pipelines.
Absolutely. And if you think one of the things that when you see all these prototypes come out using vector databases, I think I don't want to be the person that says, does it scale? But
I'll be that person. Yeah. Okay.
So unfortunately, when these things get into productions grade uses, when you have hundreds of thousands of people hitting the database and you have millions of documents, that's when you start to really see the issues with the technology. And very few people have gotten to that point. And when you get to that point, there's no escape hatch. There isn't like, we can, fix this when we get there.
Yeah. And I think scale is almost on two dimensions. One is, just scaling the performance of vector databases is not easy. And that's why you've got some amazing companies building amazing vector databases. But there's a separate scaling of kind of the use case of what you're trying to achieve, which again, there you're just down the wrong path. You could probably throw hardware and amazing technology lower down the stack on the first part of performance scaling, but you're talking a little bit about kind of
the effectiveness of it. Exactly.
Effectiveness makes sense. You touched upon GPUs, and you said if you use OpenAPI, you just don't have to worry about it. But if you don't use OpenAPI, you kind of often have to worry about, do you have enough compute? So could you elaborate a little bit more on, is that a problem? How did you solve it? And then on top of that, have you had to make some tough kind of cost trade-offs, right? And, does it, and again, even like, could it affect gross margins, for example? Anything you can provide both in terms of the complexity of getting the compute you need and the impact it may have on your cost structure?
So we are building enterprise products. And so we have enterprise pricing. And so our margins are not so it's usage-based. So, it's very hard for our costs to eat into our margins. So there's a business model sort of context that you need to define before that becomes a problem. We have pass-through costs, basically. So if our customers use more of our machines, they pay more for our machines. But if you're building a $10 a month service, fixed cost, and people are using you're giving $4 to OpenAI, and you move to GPUs, and now you have to pay $8 to GCP. It's starting to eat into your margin. So I'd say understand your business model. If you can introduce essentially a way to connect your costs or pass through the costs to the user depending on their usage, which I think is the fairest thing to do, so that you're not cross-subsidizing your user base, where the people that use it the least pay the most, and people who use the most pay the least. So some way to sort of spread out that cost, embedding that into the business model might be the safest way to protect it. Now that's the business side of things. Now GPUs are hard to find, and it's expensive. So you need to be very careful with essentially how you architect the systems. How frequently do you hit these machines? What are some of the ways in which you can reduce that? Do you always need to hit these machines? Can you do some caching layer mechanisms? So for us, there's a lot of things where the inference is exactly the same. And so we don't necessarily hit the models every single time. There's a layer of caching that sits in front of it. So there are various strategies and mechanisms that you can sort of implement to make this thing as scalable as possible.
There's a lot of elegance in having your pricing correlated to the business value, and having the business value correlated to your cost structure. And it seems like that's exactly what you're doing. One other question I just wanted to move on is, how do you measure success, right? Specifically of these kind of probabilistic AI add-ons. Are there specific analytics or any other techniques?
Again, I would look at it, I would stratify that in terms of the business layer, at the product level, and at the sort of single user level. So if you're selling to a business, there's business sort of metrics that you're looking to move. Are you able to move that using these solutions that you're building?
Yeah.
But at the product level is when things start to become really interesting, because you need feedback mechanisms to know if something's effective or not. So TikTok, for example, uses implicit metrics, things like how long do you spend on a video? Do you share it? Do you like it? As a signal to essentially know if a specific video that they served you is good or not. That has a feedback loop mechanism with the model that they're training for that specific user. And so figuring out what the implicit metrics are. So for example, if you have somebody coming in every day and using it once, you have found one use case for that user for that Gen AI product. Whereas if they're coming back and that usage is increasing over time, you've found multiple use cases. But these sorts of implicit and explicit mechanisms need to be put into the product to measure success.
So one thing you mentioned earlier was training data. And now you've talked about explicit feedback. Is your training data self-serving in the sense where product usage is generating training data, or do you have a separate training data pipeline? Could you elaborate a little bit more on how training data is generated?
So the place we have language models is in the infrastructure layer. We don't actually have language models spitting out inferences to the user. Very rarely. There's some instances where that happens, but that's probably like 5% of the whole infrastructure. If you think about chatbots, that's all they do. They constantly give back outputs to the user, and you can sort of use that back and forth to essentially train. This was a successful exchange. Let's use that to train. That was a bad exchange. Let's use that to negative train. And so the place where we use data is to train our logic.
And are you having humans annotate that data? Is that how the training data is created?
No. So we use a mix of synthetic and a small set of human, but a large amount of synthetic data. That is also validated to some extent using AI. And so the whole pipeline that generates tens of thousands of essentially annotated data is also automated.
Well, that was a great product and technology overview. Thanks for that. I'm just going to step back a bit and want to ask you a couple more strategic questions. Absolutely. I think first, longer term, how important is AI and specifically generative AI to your strategic thinking as a product, as a company?
I think there's a much broader shift happening. I think we're a consequence of that much broader shift. If it's maybe one way to think about Gen AI is we're going from essentially inorganic software to organic software. So in nature, you have these biotic and abiotic systems. You have carbon compound systems, and you have like metals and elements of the earth and things like that. we're essentially going from inorganic, which is extremely deterministic. A water molecule is H2O wherever you go, to essentially probabilistic systems. So cell divisions are probabilistic. There's an amount of it's never replicated the same way, whereas a water molecule is replicated exactly the same. And so we're moving into a world where software is essentially inorganic. You can't put it in a box and say this is what it does. This is what it might do is the world we're going into. But this is what it might do opens up a whole world of possibilities. And thinking about the whole stack of software is going to be reinvented. So I think this is as big as, say, the transistor coming into the world as an example. And I think the transistor is essentially a great way to think about this. A transistor is essentially an electronic logic gate. And the logic gate is one of the core primitives of software and programming. A logic gate is essentially if this, do that, else do this. And every piece of software is essentially a collection of logic gates. Or if the user is authenticated, depending on the request to this user, is the user requesting this piece of information, get this. If not, do this. If else, do that. So software is essentially a huge collection of logic gates. But for the first time, you can turn that logic gate into a set of essentially instructions to a machine. And you can compress essentially a stack of logic gates into one atomic unit of a generative AI model, where all of those logic gate decisions are essentially pushed into the model layers and nobody's explicitly defining anything. And so the world we're heading into and the type of software that we're building is going to shift as a consequence. And Qatalog is essentially a glimpse into what that looks like.
So the key takeaway is you've gone from hundreds of thousands of lines of code to like 9 lines of code because it's all done automatically now. No, I'm just joking, right? Like
I wouldn't say 9. The engineering team will probably send you a strongly worded letter.
No, but look, I think what's jokes apart, what's interesting is, as you said, it's the user experience that is radically different. And one thing you didn't touch upon in this is that your UX is also probabilistic that we talked about earlier. So from a user experience, how the product, both in terms of the opportunities, but also the core UX constructs. It could be a chat interface at times when it makes sense. It could be a graph at times when it makes sense, right? But then also on the kind of software and product management delivery process, right? Everything from how do you QA, how do you measure success, how do you do kind of reliability engineering, all the kind of chaos engineering that comes with it. There's going to be lots of ways to kind of look at what the best practices are. And then that's the point of this podcast. So Tariq, we're going to end the podcast asking a couple of quick fire questions that I ask all of my guests. Are you ready?
Absolutely.
What Gen AI use cases, and not enterprise knowledge retrieval, which is your bread and butter, what Gen AI use cases are you most excited by?
I think APIs that are entirely human language coded is a personal pet project of mine that I'm extremely excited by. You can essentially, if you can now code using English, how do you build interfaces into that code? And what does that enable people to do? There's a whole world, I think, that will open up as a consequence of that. So bringing structure to essentially non-coders to enable services is an exciting, I think, avenue that hasn't been explored as much and wasn't possible like before this whole explosion happened.
We have been constantly constrained by the supply of software engineers, and it looks like that may be relaxing that a little bit. Wonderful. What about open source versus closed source? I think I can guess it, but which Gen AI models do you think you will win out in the long run?
I think this is going to play the same sort of arc as Linux. There'll be one core or 2 or 3 core sort of providers that will be held up by the community. And because of the utility nature of it, there'll be lots of people contributing to these things. In the long run, all these proprietary LLMs will have a place, just like, enterprises need proprietary mechanisms and support and services and things like that. But even then, it's most likely that it's going to be built around an open core engine that is innovating at a much faster rate than any of this stuff. I think the technology, everything is trending to smaller models, more precise, more defined problem spaces, which require much less data. So the training costs are much lower.
Yeah, it's encouraging to see some of the, let's call them small language models and how their accuracy is comparable with significantly lower parameters and even data sets.
Yeah.
And then lastly, what impact do you think Gen AI will have on the velocity of your product development in your organization?
I think it's 100x, if not 200x. We couldn't have done this with 25 engineers 3 years ago. It's impossible.
Yeah.
It just is impossible.
Well, that's a great place to a note to end this conversation. Highly optimistic, and I think you're exactly right. Exciting times ahead. Of course, you're a leader. Your company Qatalog is a leader in this, and this has been a very enjoyable and insightful conversation. I think our listeners will love it. Where can people either find you and the Qatalog team if they want to learn more about Qatalog?
It's qatalog.com. Qatalog. I'm on Twitter as Tariq Rauf, as my name. And the team is also on Twitter at Qatalog.
All right, at Qatalog with a Q. Thanks a lot, Tariq.
Well, thanks for having me, Gaurav. Speak soon.
Thank you for listening to this episode of AI Unveiled. If you want to learn more about Next 47 and our role in helping AI enterprise founders, be sure to check us out at next47.com. That's next47.com. If you enjoyed this episode, please consider subscribing and rating us on whichever platform you use for podcasts. I'm Gaurav Kotak, partner at Next 47. Thanks again for tuning in, and I'll see you soon.